Hi everyone, I hope you're doing okay. My name is Romero Galo and today we talk about exponential functions. And one of our goals today is to answer the following question. Would you rather be giving $1,000 today or be giving $1 today and each day be giving double what you were given the day before for 10 days? So think about it. And the end of this section, let me know if you change your mind, and really want to know your thoughts about it. Moreover, we learn a different way to write a number 1 using exponentials. So let's see. So let's start. Let A be a fixed constant. Which kind of constant? Like, you're gonna think about any number. Actually, any number? No. Two conditions for this. A should be positive, and also A should be different than 1. So if you pick a constant and you fixed, and this constant is positive and different than 1, you're going to be able to define our exponential function, a to the power x. So why the name is exponential function? Because our variable here, it is in the exponent. Great. So I'm going to ask you, tell me one constant greater than 0 and different than 1. Okay, maybe 3. So you're saying f of x equals to 3 to the power x. It is one example of exponential function. So that's your first example. You can tell me another one. Belmiro, what about f of x equals to minus 2 to the power x? No, that's not an example of exponential function because it is not part of our condition. We're going to be fixing our constant, and this constant should be greater than 0 and different than 1. Minus 2, it is negative, so it is not going to be part of our definition. So now, let's take a look at a to the power x again, in a general situation. But now let's think that our exponent is a natural number. Any natural number, tell me one. Okay, maybe 2. So what it means when I have a to the power 2? It means I have to multiply a by itself. It means I have a times a. Great. What's going to happen when I have a cubed? Or a to the power 3. It means I have to multiply a by itself 3 times. What's going to happen if I have a to the power 4? I have to multiply a by itself 4 times. Now you start believing me. That's notation. It is not that bad. Because could you imagine if I had a to the power 2021? I have to multiply a by itself 2021 times. That's... I will be tired. Now, I think you're gonna believe that mathematicians, they don't wanna annoy you with those extremely hard notations that you're gonna see in the future. When you have the sum, when you have this integral, when you have this kind of general product, and when you have some kind of notations like that. Yeah, we are not being lazy. We are not only saving trees, but also we are saving some time. You'd be extremely huge doing this product. Let's see a couple of examples. You could have asked me at the beginning why I cannot use the number 1 as my fixed constant at the beginning. But I think now it makes sense, because if I had 1 to the power x, I know that I have to multiply 1 times 1 times 1 a couple of times, but what is going to be this product? For example, if I had 1 to the power 10, I have to multiply 1 by itself 10 times. 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know this product doesn't matter. It is 1. Now, let's talk about one special notation when you have the following situation. For example, 1 over a times n times. We already saw when I have this product, I can use the exponential notation. That's 1 over a to the power n. But now I'm going to define situations like that as a to the power minus n. And this n here, this minus in front, doesn't represent a negative number. It's just going to make us look at this object exactly like that. 1 over a to the power n. Now I'm going to be using an app called Procreate, because I want to make comments about some properties related to exponentials. I basically took here, I'm going to comment about 4. I select 4 properties related to exponentials that we're going to be talking today. First one, if I'm going to take values a greater than 0 and also different than 1, and x and y real values, we have a power x times a power y. That's the same as a to the power x plus y. Okay, I'm not going to be proving those properties here today. I'm just going to show a couple of examples, just trying to convince you that makes sense. Let's think about our value a, that is equals to our value x, for example, is 3. So our value a, I already picked that, was 2, and y, let's think about it, is 4. So what it means, 2 to the power 3, I'm multiplying 2 by itself 3 times. 2 to the power 4, I'm multiplying 2 by itself 4 times. So in total, I'm multiplying 2 by itself 1, 2, 3, 4, 5, 6, 7 times. So it means that's 2 to the power 7. But 2 to the power 7 is the same as 2 to the power 3 plus 4. That's just one example. But you can think about, if you have a to the power x, a to the power y, think about x and y are natural numbers. So a to the power x, I'm multiplying a by itself x times. And a to the power y, I'm multiplying a by itself y times. So in total, I should have a to the power x plus y, because I'm multiplying a by itself x plus y times. Okay, you can consider that was a proof. Let's see property number 2. property number 2. So this one, number 2. So again, we're going to be considering here A, it is positive, and A, it is not 1. And I'm also going to be assuming that X and Y are real numbers, or real values. You can pick any value. But we are giving some examples, so we're using general natural numbers. So number 2, we're going to be thinking that I have the following situation: A to the power X to the power Y. So that's going to be equals to A to the power XY. So Y, again, let's see one example. Again, let's use 2, right? 2 is like a nice number. 2 to the power 3 to the power 4. So what it means first, I'm gonna solve this power 4. It means I have to multiply 2 to the power 3 by itself 4 times. So that's, I'm applying the definition. You remember, you solve the parentheses first. I'm gonna solve this guy here first, because what's like outside the parentheses, so I'm doing this. Now, take a look closer. 2 to the power 3 is 2 times 2 times 2, but I have to do this 4 times. So this came from there, and also I'm gonna have other products from this one, and for the other 2, I'm gonna have this, and for the last. Great. So how many times 2 is multiplying by itself? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I have 2 to the power 12. That's exactly 3 times 4. Okay, very nice. So since I already told you at the beginning, I'm not gonna prove in the properties. I'm just gonna give some examples to convince you the property makes sense, and I'm picking X and Y natural numbers. Okay, I have 2 more properties. Great. The third one, again, same conditions for A, X, and Y. I just want to tell you that when I have A to the power X over A to the power Y, it is the same as having A to the power X minus Y. Why do we have that? Think about 2, let's use it now, power 5 over 2 to the power 3. Just one example. 2 to the power 5th, I'm multiplying 2 by itself 5 times, and 2 cubed, I'm multiplying 2 by itself 3 times. Since I just have products at the top and the bottom, I can simplify our expression. Great. It means I have 2 squared. But 2 to the power 2 is exactly the difference between 5 and 3. That was exactly what the property told us. Great. Being more general, you can think that if you have actually A to the power X over A to the power Y, if you have natural numbers X and Y, you have A times A X times, you multiply a by itself x times. And at the bottom, you have a times a times a y times. And then you're going to be able to simplify those because you have a product at the top and the bottom. So you're going to simplify a couple of values. At the end of the day, you're going to have exactly the difference between x and y. Because you're going to be canceling the number of y's that you have at the bottom with the number of x's that you have at the top. Great, right? I hope it makes some sense. And finally, the last property that I'm going to make comments here today is when we have property number 4, when you have a and b positive constants, and all of them again different than 1. If you had x real value, when you multiply a times b, and you have this at the power x, it means that I have also a to the power x times b to the power x. Okay, why? Let's see. One example. Think you have 2 times 3 to the power 4. 2 times 3, it is 6. So they're saying you have 6 to the power 4. 6 to the power 4, you have to multiply 6 by itself 4 times. But 6 again is 2 times 3. So instead of looking 6 times 6 times 6 times 6 4 times, you can think that you have actually 2 times 3 times 2 times 3 times 2 times 3 times 2 times 3. 4 times, right? 1, 2, 3, and 4. How many 2's do you have? 1, 2, 3, 4. 2 to the power 4. The same as for 3. And that's exactly what your property told you at the beginning. Great, fantastic. With that, I want to just discuss pretty quickly why do we have the following situation. Why do we have y a to the power 0, it is equal to 1? That's a good question. But if you think about, one of our properties was exactly what we need. Because I told you here, property number 3, that we had this. So let's think about what happened if x it is equals to y in the property 3. So let's come back here. What would happen if I have x equals y using the property 3? I have a to the power x over a to the power y. It is actually equals to a x minus y. But if x it is equals to y, I'm gonna have, so if x it is equals to y, I'm gonna have the following. A over x over a over x is exactly a over a to the power x minus x, but x minus x, 0. Great, so a to the power 0 is exactly a to the power x over a to the power x. But same value, It is 1. So it doesn't matter which kind of constant, positive, different than 1 I'm going to pick, always at 0. It is going to be equals to 1. Oh, Belmiro, what's going to happen when I have 2 to the power 0? It is 1. What is going to happen when I have 3 to the power 0? It's going to be 1. What's going to happen when I have 2021 to the power 0? It is also going to be 1. It doesn't matter which kind of positive constant different than 1 that I pick. Oh, it's going to be 1. Fantastic. And finally, let's answer our question from the beginning. What do you prefer, having $1,000 a day or getting $1 at the day 0? So today you get 1, and during 10 days I'm gonna be doubling the money and give to you. It means day 1 I'm gonna double it. I'm gonna give you 2. Day 2 I'm gonna double the previous day and I give you 4. Day 3 I'm gonna be doubling this 4, so I'm gonna give you 8, and I'm gonna keep doing this for 10 days, and then we're gonna have the day 10, and also you keep what I had actually previously. So how much money I'm gonna be giving to you at the day 10? Just notice here, 1, it is the same as 2 to the power 0. 2 is the same 2 to the power 1. 4 is the same as 2 to the power 2. And 8 is the same as 2 to the power 3. So what you'd think that you would have at a day 10? Exactly, 2 to the power 10. That's $1,024 that you're gonna receive exactly at the day 10, but also you have the money that you already got in the days before. So that's quite a lot, and it is much more than $1,000. But you can say maybe like, oh, but if I buy some stocks, I love like the stock market, I'm gonna buy Tesla, I'm gonna buy 1 share of Tesla, probably is gonna grow a lot. Yeah, it's gonna grow a lot, but not more than let's say 30%, because at the day 9 you're gonna receive $512. So when you add whatever you're gonna receive like the day 10, you're gonna have enough money. So we're not gonna find a way to increase your money more than 50% in 10 days, like not even Tesla anymore. Thanks for watching this video. I hope you could learn some math with me. So give us a like, subscribe to the channel, make comments, suggestions, and see you soon. Bye!